2 and 1. Okay, so let the fun begin. So here's another one. This one is in the show notes. When you go down to the show notes, okay, so below, if you hit down on the show notes, you'll notice you're going to be able to download this particular little mini quiz on radicals. Now, it should challenge you a little bit. So the hope is that once you review kind of the entire playlist on radicals, I can put up a link up above there, then you should be able to solve these questions. So there's a few questions in here. It's basically just a one sheet, and then there's 4 questions here, and then 7 questions here. So try those questions on your own, and then you can come back to this video and then watch me solve all of them. All right, so that's what I'm going to do right now. Okay, let's get started. So question number 1. So within this one, so what I'm going to do is, okay, so here it says explain why the answer given is wrong and then provide the correct answer. So the correct answer here, because you have the square root of 7 plus square root of 7, the correct answer is this. Okay, so 2 multiplied by the square root of 7, because you have 2 of them. So it looks like what they have done wrong is they probably just added the radicand. So they probably did 7 plus 7, and then that would be 14, and that is incorrect. Okay, so the answer is, it's because you have just a single 1 in here and a single 1. Okay, so that's the answer. So that's question 1. Question 2. So let's take a look at this one. So within here, so notice the radicand that we have is the 3 and then a 2. Now it is the cubed root, okay? So it's basically the third root of 3 and then the third root of 2. Now it looks like what they have done is they have basically, because they got a 7, so it looks like they added the 2 plus the 5, which gave you 7, and then they added the 3 plus the 2, which gave you the 5. So that you cannot definitely do. So the only time you can add them is if the radicands were the same in this case. So here there's actually not much to do. So the correct answer is simply, okay, as it is stated. We can't really do anything else. So, and the reason is because these two things are different. All right, so these might be the same. So they're both the third root, but they are different. So they're not like terms. So that is it. That's all you can do for question 2. For question number 3, so if I take a look, so this one, so you have multiplication. So you have 3 times negative 4. All right, so this is what we have here. So 3 times negative 4. So that's going to be negative 12, so that's correct. But now notice that they have forgotten to multiply the square root of 2 times the square root of 2. So within here, so the way that we would do it is, this is basically 3 times negative 4 times the square root of 2 times the square root of 2. So this correctly is negative 12. But if you do this, well, the square root of 2 times the square root of 2 is just 2. So now if you multiply them, the answer is negative 24. So that would have been actually your final answer here. So that's interesting. All right, so that's what we have there. Okay, so now what about question number 4? Okay, so let's take a look at that. So for question 4, which is this one, so we have a division. So now notice, so the 4 and then the 2. So 4 divided by 2 is actually 2, so that's correct. So we have 2 there. Now, notice that what we can do is, so we have 27 divided by 9, so we can put the entire thing over the radical symbol. And now 27 divided by 9, yeah, so this is going to be 2. Now 9 goes into 27 3 times, and that would be your answer. Now notice what they have done, it looks like, so they got 18. So most likely what they did is they subtracted the 9, which gave them the 18, and that would have been incorrect, right? Because division, you're actually going to be dividing. So you can put the whole thing over the radical, and 27 divided by 9 is just 3. Now we can't simplify this any further. That's all that it would be. So that's kind of the first 4 questions, and then trying to see where the errors are. All right, so that's that. Great. Now, next, it says simplify. So we want to be able to simplify. Do not use a calculator and leave answer as lowest radical if necessary. So kind of in lowest terms as possible. All right, so we'll do that. So with these and with any radicals, so as you take a look at these, whenever you're taking and you want to be simplified, you always use prime factorization. So with prime factorization, so we can break this thing down as much as possible. So 150, well, we know that 2 goes into this, so it's going to be 2 times 75. Now 75 is 3 times 25, so it's going to be 2 times 3 times 25. And notice the 25 is just 5 squared. So if you simplify this, this is going to be now 5 squared, which we're going to be able to take out, and then 2 times 3 is going to remain underneath. So this is going to be 5, and then the square root of 6. And that's as far as we can simplify question 1. Okay, so number 2. Okay, so let's try that one. This one looks a little bit tougher, I guess. So notice we have 588, so it's the square root. So let's try to prime factorize this this thing. So it's going to be 2 times, now, so 2 into 588 is going to go, now if you, since we can't use calculator, it's going to be 588. So this goes 2 times 4, 1, 18, 9. That's going to be 18, bring down the 8, so that's 294. Okay, so that's the first one. Now, this can again be divided by 2 times, so this one's a little bit easier, so that's going to be 147. So you can check that, so 2 goes into 294. Now, 147, well, 2 won't go into it, but 3, so 1 plus 4 is 5, 5 plus 7 is 12, so 3 goes into this. So I'm using the divisibility, so how many? 3, that's going to be 49. Okay, and then 49 is 7 times 7. So this is 2 squared times 3 times 7 squared, so I'm going to put the 7 squared here. Now if you take the square root of this, then obviously the 2 and the 7 will come out in front, and 2 times 7 is 14. And then you have 3 underneath the radical. And that's in simplified form. That's as far as we can take number 2. So this was actually a really nice one to force yourself to try to prime factorize. Now, number 3, so this one is neat. So I guess it brings you back to kind of fractional exponents. If you've forgotten, because radicals are just exponents in fractional form. So I'll put a link up above there, all right, to the fractional exponents if you've forgotten it. So this is nothing else but simply the cubed root, or the third root of 240. All right, so that's the same thing as saying 240 to the exponent of 1 over 3. All right, well, now we just prime factorize. So we have 240, so it's going to be 2 times 120, 2 times 260. Okay, well, let's keep going. 2 times 30, and then 2. All right, I'm going to start adding them up. 1, 2, 3, then we have another one, so 4. This is going to be 15. And actually, this is as far as you can take it. All right, so we have that, because 15 is 3 times 5. So this is going to be 2 to the power of 4, 3 times 5. Now, if you want the cubed root of this, well, we can only take out 2 to the 3, so the one of the 2's will remain behind. All right, so it's going to be that. That's what you would have there. And then this 2 will come out, so your answer will be 2. And then the third root, now 2 times 3 times 5. So 2 times 3 is 6. 6 times 5 is 30. So that's it. That would have been the answer. Now, please don't confuse here. So the way that we write it is a little tricky. This 3 doesn't mean that 2, it's 2 to the power of 3. So I guess we have to kind of be careful how we write this, make it more explicit. So maybe you just write it, this way, that it's very clear that the 3, okay, is for the radical. Because if you put it as 2 to the 3, obviously that's different. All right, so just be careful, I guess, how you write it and present it to your teachers. So that was question number 3. Let me erase this junk. So that's gone. Let's take a look. So question 4. So this one, the way that it's written, it looks like we can't do anything because the radicand is different, right? Because we have 12 and then 3. But well, let's see if we can reduce this. So this is going to be 5, and then under the radical, so 12 is 2 times 6, and 2 times 6, so that's 2 times 2 times 3. So this is 2 squared times 3 minus 3, and square root of 3. So now this 2 squared will come out, so that's going to be 5 times the 2, which is 10. And now, look at that. Now we can work with these because these are now like terms. So the answer is going to be 7. That's 10 minus 3. And then you have that. All right? So that's interesting. Okay, so this is what we have. Okay, so question number 5. Let me remove this. So question number 5, which is this one. Again, it looks a little complicated there. Now you have the square root, and then you have the cubed root of 2, and then the cubed root of 16. So we can't really combine the square root with the cubed roots, but let's see if we can simplify the rest. All right. So here, so I'm gonna try to see what I can do with these. The cubed root of 2, I can't do any. I can't simplify that because the 2 is already a prime number that you can't really reduce in any way. Now 16, on the other hand, 16. So what we have is 16. So notice this. Okay, so well, it's divisible by 2, right? So it's 2 times 8. Now 8 is 2 times 2 times 2. So actually, so 16 is 2 to the 4. So we can certainly reduce this. So this is the cubed root. I'm going to take 2 to the cubed and then times 2. So that's the same thing. And that's going to be 2. Again, the 3 is there. So that's that. Okay. So now what do we have? We have 12 square root of 2 plus 5. All right, this is the cubed root of 2 minus 2. Okay, so we can reduce these two. So 5 minus 2 is 3. All right, the cubed there will remain. Sorry about that. This is going to be 3 cubed root of that. So that's that. So that's 5 minus 2. Now, can I reduce this any further? So the way that it is written, it's pretty much all that you can do. Now you cannot say 12 plus 3, all right, because these are two different things. This is square root and this is cubed root. So that's as far as we can take that one. Okay, great. So that's that. Question number 6. So let's see this one. So we have, so this is a lot of stuff here. Okay, let's clean it up a bit. So we have this. We can't do anything with that. Then we have it multiplied by, so those are the brackets there. We have the square root of 3, because that's the same thing as this. And then multiplied by 3 and square root of 2. Okay. So that's not bad. So this is just all multiplication. All right, so if we're going to multiply, so 4, the number here is 1. So 4 times 1 times 3, so that's 12. Now the radicals, so notice we can take the radicals and multiply all of them together. So that's going to be 2 times the 3, because they have the same, so they're all square roots. So we have this. So this is going to be 2 squared times 3 Okay, the 12 is in front. This 2 will now come out, and 2 times 12 is 24. This one actually works out pretty nice. So that's 24, and then times square root of 3. So that's your answer there. All right, so question 7, which is your last one on this, quiz slash test. I mean, I guess the questions were kind of hard. Okay, so let's see this. So I had a 3 and a 3. Okay, so if I blow this up here. So we can work with this, definitely. So 16 divided by 4, that's going to be 4. Okay, so that's 16 divided by 4. Now, okay, because I have the cubed root of 189 divided by 40. So let me reduce this 189 by 40, and hopefully it'll give me something that I can work with. All right. So I'm just looking at it. Let's see what we have here. Well, 189 is not divisible by 2. So how about by 3? So we have 1, 8, so 9. So yeah, it is divisible by 3. So 3 goes into 189. 3 goes into 18 6 times. So 63. So it's going to be that. And now I can again divide by 3. So it's going to be 3 times 3. And that's going to be times 21. And again by 3. So 3 times 3 times 3 times 7. So look at that. So this basically is the cubed root of, this is 3 cubed times 7. That's in the numerator. And then in the denominator, so for the 40, so this is 2 times 20. 2 times 2 times 10, and 2 times 2 times 2 times 5. So this is going to be 2 cubed times 5. So perfect. So this is what we have. Let's not forget this 4. So we have 4. Now, the 3 cubed and the 2 cubed will come out from under the radical sign. So that's going to be 3 over 2. And then in the radical sign, what will remain is just 7 over 5. So simplifying this, so notice, so 4, well, 2 goes into 4 2 times. So 2 times 3 is 6. And your answer is going to be this. That's as simplified as you can have it. That's a great question to test yourself on and see how well you understand this, right? Simplifying all these radicals. All right, so thanks for watching. I wonder how many you got right. You can put that down in the comments. So this is definitely a worthy quiz, not an easy one at all for anyone who's brave enough to try it. Okay, see you in future videos. Bye, everybody.